Welcome back, everybody. In the past, we talked about derivatives and said that it was the slope of the tangent line. Well, now let's see how the slope relates to the function. This is one of the first major applications that we're going to talk about in this class. So let's take a look at a graph. Doesn't matter what graph it is. We're just looking at the slope of the line. So the tangent line looks like that, right? Increasing, increase, right? Positive, 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 until we get to that point, right? Until we get to this point, it's all positive. And then we start to go down, right? So now it's negative. So as long as my slope was positive, as long as f prime of x is greater than 0, my function is increasing. And we see it right here. Every tangent line is going upward, hence the slope is positive, until we get to a point where our slope is 0, and then it starts heading down. And as long as the slope is negative, so in this case the slope is negative, slope is negative, slope is negative, then it becomes 0 right about there. As long as then the function is decreasing. So if f prime of x is less than 0, and again, over here, the function is once again, the slope is positive, positive, positive. So the function is increasing once again. All right, so in the last video, we talked about critical numbers. So let's review for a minute. All right, so a critical number is the spot on the x-axis so it's the x value of the point where my derivative equals 0 or is undefined. Either one. So for example, let's look at the graph above, and I'll change back to green. The point over here where my tangent line was horizontal, and the point down here where my tangent line was horizontal, right? Those would be considered critical points because you would have an x and a y value. Critical number would just be the x value, but you can call them critical numbers, critical points, either one, but both of right? So in this case, my critical number would be a maximum. Here it would be a minimum. Now, a critical number doesn't always have to be a maximum or a minimum. It could be. It's the only spot where it's possible. I'm going to do a quick drawing of a graph where your critical number, critical point, will not be a max or a min. I can draw that better. Okay. So here, my critical point is right there at 0, because as you can see, I can make a horizontal tangent line right there. But it's neither a max nor a min. All right, so it is possible to have a critical point that's neither a max nor a min, but it's the only spot that we need to check. All right, so let's take a moment to find some critical numbers, and then we'll try to start putting it together with maximum or minimum. So my example, find the critical number. for f of x equals x to the 3/5 times 4 minus x. All right. So why don't you pause the video right now and work through the derivative. I'm going to work through some of the derivatives, not necessarily all of them at this point because you guys are experts. But let's find the derivative and make sure it's in most simple form. All right, so before I do the derivative, I'm going to distribute because I'd rather use the power rule than the product rule. So I have 4x to the 3/5 minus x to the 8/5. All right, and now when I do f prime of x, let's make that better prime. That equals 12/5 x to the negative 2/5 minus 8/5 x to the 3/5. And now we need to simplify just a little bit more. We have a negative exponent, so I'm going to make that and in order to get a common denominator, I'm going to multiply top and bottom times x to the 2/5 over x to the 2/5. So then I get minus 8x, and it's the same denominator, 5 times x to the 2/5. Looks good to me. And I got to set this equal to 0. All right, because we need to know where it equals 0 and where it is undefined. So let's start with undefined. All right, and it's undefined when the bottom here equals 0. So that equals 0 when x equals 0. So there's your first critical number. All right, now where it equals 0 is where the numerator equals 0. So I have 12 minus 8x equals 0. Then I have 8x equals 12. X equals 12 over 8, which is 3/2. All right, so x equals 0, x equals 3/2 are your critical numbers. All right, so how do we put this all together with max and min? All right, so I'm going to give a new example. All right, so I'm going to say find the local extrema for f of x equals x cubed minus 5x squared plus 8x minus 4. All right, so remember the local extrema, there could be many local max and mins. Only one absolute, but we're looking for local ones right now. And the first thing we're going to do is we're going to find our derivative. Because remember, the first thing we need to do is find our critical number. So actually, let me list that. Find the critical numbers. All right, and the way we find the critical numbers is we start with the derivative. So f prime of x equals 3x squared minus 10x plus 8. And again, that's a power rule. We set that equal to 0. And what I'd like you to do now is pause the video. And I want you to solve this, right? There are indeed two answers. go ahead, do the algebra, solve this, and I'll talk about the answer on the back end. All right. So in order to solve this, we need to factor it. So I'm going to use the AC method. So 8 times 3 is 24. So I have 3x squared minus 6x minus 4x plus 8 equals 0. There are my groups. So I have 3x on the outside, and I'm left with x minus 2. And then I'm going to take a negative 4 out, and I'm left with x minus 2. So then I have 3x minus 4, x minus 2 equals 0. All right, so now I got to solve both of these. So I get 3x minus 4 equals 0, 3x equals 4, x equals 4/3, x minus 2 equals 0, x equals 2. And now we're going to go make a chart. Now the chart it's basically a test for max and min, but really what we're testing for is we're testing for increasing and decreasing, all right? And here's the way we're going to make that chart. So okay, so my intervals are basically going to be dictated by my critical number. So I have negative infinity all the way to 4/3. Now the reason I go up to the critical number is because the critical number is going to be where the slope of my tangent line equals 0. So let's take a look at the graph that we did earlier. All right. So for example, up here, right, my critical number up here, my function went from increasing to decreasing. So if it goes from increasing to decreasing, my critical number is a maximum. Here it went from decreasing to increasing, my critical number was a minimum. All right, so basically what I want to know is, am I increasing or decreasing up to the critical number? Does the critical number force me to change direction? All right, so what I want to, right, so for example, if I'm increasing up to, right, from negative infinity all the way to 4/3, I'm not changing direction until 4/3 is the first time that I'm allowed to change direction. All right, then I'm going to 4/3 to 2 and 2 to infinity, because once again, right, between 4/3 and 2, I'm going in the same direction. 2 is the only place where I could change direction. Therefore, I only really need to test one number in the interval. For example, here I'll test 0, here I'll test 5/3, here I'll test 3, because if the sign of my derivative is positive, it's going to be positive for all values in that interval. If you don't believe me, test a couple of them. But I'm telling you, one is going to be enough. So what you do is you take the test point, my test point was 0, and you run it through the derivative. You take the test point of 5/3, run it through the derivative. Take the test point of 3, run it through the derivative. Now you could do this a little bit quicker because you're only looking to see if it's a positive number or negative number. You don't care what the number is. You only care if it's positive or negative. All right, so I'm going to ask you to pause the video, take all 3 values, right? You can even use this to run it through the derivative, right? To see if you have a positive or a negative number. All right, and we'll talk about the answer on the back end. All right, so I'm going to do one with you, and then we'll just talk about the others. I'm going to take 0. If I plug 0 in, right, 3 times 0 is 0, minus 4 is a negative number. 0 minus 2 is a negative number. A negative times a negative gives you a positive. All right? And let's take 3 and I'll put 3 through. 3 times 3 is 9 minus 4 is a positive number. 3 minus 2 is a positive number. Positive times a positive gives you a positive. All right? And hopefully you got the same thing I did. 5/3 is indeed a negative number because 5 minus 4 is, negative. So this is increasing, decreasing, increasing. So that's all the table's going to tell you. Now, you need to conclude from this table what's happening. So if the function is going up to 4/3 and then changes direction and goes down, 4/3 is a maximum. All right. If the function is going down to 2 and then going up once it hits 2 is a minimum. All right, so those are the conclusions that you draw from this chart. It's very, very important that you're able to get if it's a maximum or a minimum. It's very important to get increasing, decreasing, but then from there to take the next step and get, is it a maximum? Is it a minimum? All right, so let's try one now, but let's limit the domain. We don't always have to go to infinity, all right? And the way we know we're going to limit the domain is the problem's going to tell you. So if I have f of x equals negative 2x squared plus 16x minus 27, right? And here's your domain. Your domain is from 2 to 4 inclusive. We're going to start out the same way. We're going to find the derivative. So f prime of x equals negative 4x plus 16. I'm going to set this equal to 0. And I'm going to say 4x equals 16 and x equals 4. So 4 is a critical number. It happens to be at the very end of my domain. Now the key here is the critical number. The only reason to use a critical number is if it's in the domain. Okay? In this case, in this kind of problem, you could potentially get a critical number outside of the domain. If you get one outside of the domain, don't use it. All right? So the next step after that is going to divert. So this was step 1. The next step says take the extremes and the critical number. I'm going to use Cn for critical number and plug them into the function. This one's right? So if there's a limited domain, a little bit easier, right? I'm going to figure out, so I need to know what f of 2 is and f of 4. So I'm going to ask you, all right, so I need to know f of 2 and f of 4. At this point, why don't you pause the video, take 2, run it through your function, take 4, run it through your function, and remember, the critical number and the extreme are the same, right? So you only have to do the extremes. And the biggest number will be the maximum. The smaller number will be your minimum. So go ahead and do that. We'll talk about the answer on the back end. Okay. Hopefully you paused the video. I got f of 2 to equal negative 3. I got f of 4 to equal 5. So here is your max, here is your min. If a critical number had gone in between the two extremes, you would have run the critical number through the function as well. All right, let's try one more. Let's see if we can get one where the critical number is in between the extremes. So I've got f of x equals x cubed minus 3x squared plus 1 and there is your limited domain. All right, so first thing I'm going to do is I'm going to find my derivative. And my derivative is 3x squared minus 6x. I'm going to set that equal to 0. Now we're going to go ahead and solve that. I get 3x times x minus 2 equals 0. So I get x equals 0 and x equals 2. So there are my two critical numbers. So now I need 4 things from you. I need to know f of negative 1/2. I need to know f of 0. I need to know f of 2. And I need to know f, here, let me just write it, f of 4. All right, I'm going to scroll back up so you can see the original function. You're going to take each one of those numbers, plug them into the original function, and we'll talk about the answers on the back end and the conclusions. Okay, so hopefully you paused the video and did the work. I got 1/8 for f of negative 1/2. For f of 4, I got 17. For f of 2, I got negative 3. For f of 0, I got 1. All right, so now once again, the biggest is going to be your maximum. So again, here is your, right? So if I were to say, where is my maximum? My maximum is at 4. What is my maximum? My maximum is 17. All right. And your minimum is going to be here. My minimum is x equals 2. Right? The value of my minimum is negative 3. All right. So that's the basic idea behind max and min. We did one where we went globally from negative infinity to positive infinity. We did a couple more where we limited the domain. A lot more practice to do. Thanks for listening, and I'll see you all next time.